value of Trig identities is they give you tools that you can then use to solve Trig problems. If you know some fact about Trig functions, and you have some problem that say involves a triangle, if you remember that identity, that fact about Trig functions, that potentially gives you a truth. So the goal today is just to go through and prove more identities involving Trig functions. And right now we have one big tool. That tool is take the equation you want to prove. Maybe one side looks more complicated than the other. Take the side that looks more complicated, simplify it, explain every step. That's an important part. And whatever you get at the end had better be the thing on the other side of the equation. So let's see. So, if I recall correctly, last time I had you guys prove the third Pythagorean identity. Is that right? Or did we have time to go through that one? Well, we didn't have time to go through it, but you guys completed a proof there? Okay, well, talk me through your proof. Tell me why cotangent of theta squared plus 1 should always be equal to cosecant squared of theta. Yeah.
So my first step was, I guess I kind of combined. I expressed everything in terms of sine and cosine, and then I got a common denominator.
Great. And I guess you also decided this was the more complicated side.
Yeah.
So we'll start with that side. So cotangent squared of theta plus 1 is equal to cosine squared theta divided by sine squared theta plus 1 by Louis expressing. And then you said you got a common denominator. So that means you just rewrote that 1.
Yep.
Equals cosine squared theta over sine squared theta plus sine squared theta over sine squared theta by expressing in terms of sine and cosine and getting a common denominator. Very good. All right, what happened next?
Then you can use your Pythagorean identity on the top, and that will just become 1.
So, cotangent squared theta plus 1. Well, maybe I'll devote a step to also adding the fractions. Gesundheit. By Pythagoras. Nice. And what next?
Reciprocal.
So the 1 over sine squared is the same as cosecant squared. So cotangent squared theta plus 1 is equal to cosecant squared theta as cosecant is equal to 1 over sine. And that completes it. Cool. Everyone feel pretty okay? So my goal for the rest of this note packet is just, here are some more trig identities. Let's get through as many of them as we get through. And as a reminder of the homework associated with this particular packet, if I'm asking you to prove a trig identity, I've already told you the equation that you want to get at the end. So, but you know what the answer is. I really do only care about your work. I want your supporting work to be fully explained. That means lots of details, sentences explaining every step. Something which maybe you would want to do in a single line in really, really little writing. Probably should take a few lines in writing that's big enough to read, with like words. So let's keep on going. Let's try to prove this identity. cosine of alpha divided by 1 minus sine of alpha is always the same as 1 plus the sine of alpha divided by cosine of alpha. Let's do this. Lamp. So, in looking at that equation, so right now our strategy is start with the more complicated side, simplify it till you get to the other side. Is one side of that equation obviously more complicated than the other? Is it actually though? I mean, they're about the same. So there's not an obvious candidate to start with. I guess which side do you guys want to begin with?
Left side.
The left side. That's fair enough. Let's just start with the left-hand side, when in doubt. So you notice I'm going to go through this one twice. That same identity, I'll prove it 2 different ways. So let's start with the allegedly more complicated side. I guess it's complicated in the denominator, so maybe that's a reasonable reason to call it the more complicated side. I'm going to take that and do some algebra to it. And I certainly don't see anything obvious just by looking at that side. But maybe I see one thing. It looks like the denominator there, 1 minus sine of alpha, like that looks an awful lot like the numerator on the other side. Like it looks like the algebraic conjugate of it. So, I mean, that's also just generally a nice thing to do. Multiplying and dividing by the conjugate might make the denominator nicer. No guarantees, but let's see what happens. Let's multiply and divide by the same thing as is in the denominator, but with a plus sign. And that seems like a reasonable thing to do because I want to get a 1 plus sine of alpha into the numerator. This will put a 1 plus sine of alpha into the numerator. So let's see what happens. So that will give me cosine of alpha times 1 plus sine alpha divided by 1 minus sine alpha 1 plus sine alpha. All right. Fair enough. So the next line indicates to just use the Pythagorean identity, but what's written right there, do you see any sine squareds? Do you almost see a sine squared though? Like in the denominator?
One side squared, 2.
So this denominator will become 1 minus sine squared. So that's handy. So this will become cosine alpha times 1 plus sine alpha divided by 1 minus sine squared alpha by distributing and now I allege that I can use the Pythagorean identity. What does the Pythagorean, how can you use the Pythagorean identity at this point?
Well, we know that cosine plus sine, or cosine squared plus sine squared equals 1. So just to get cosine, you're going to subtract over your sine squared, which is what the denominator is.
Yeah, so the observation, and this is being made off to the side. Right, so cosine squared plus sine squared is always equal to 1. So that means cosine squared is always the same as 1 minus sine squared. Do you see 1 minus sine squared in that fraction? Yeah, so that means we can replace it with cosine squared. So by the Pythagorean identity, 1 minus sine squared alpha is equal to cosine squared alpha. So this whole thing will become cosine alpha 1 plus sine alpha, not enough space, equal to cosine alpha 1 plus sine alpha divided by cosine squared alpha. And I've gone slightly off script from the original plan, so instructions maybe don't make sense. Do you see any cancellation? The next step says to cancel.
Cosine.
Yeah, there's a cosine in the numerator and denominator. So you can cancel that, and what do you wind up with?
1 plus sine alpha over cosine alpha.
Cool. Is that what we wanted to wind up with?
Yep.
So we're done. This completes the proof. So sometimes what you see is neither side looks more complicated. And what we actually wound up doing is we wound up taking one of the sides and making it complicated off, and then doing some stuff and simplifying it. Right? We multiplied and divided by a thing. That's not a simplification, that's a complication. It made it more complicated looking. But then that gave us space to walk. We shook it down, simplified in a different way than we complicated it, and we got down to the other side. So that requires a step of just cleverness to begin with, and then it was like algorithmic almost. But let's see if we can come up with another way of thinking about this, which is more intuitive. So instead of taking one side of the equation and manipulating it, let's manipulate the whole equality. We'll manipulate both sides of it. As long as we do a move which resolves equality at every step, we can come up with a proof this way. Let's try to do it. So let's try to prove this exact same thing. So as long as we do something to both sides of the equation, we'll resolve the equation. We can manipulate that equation, which we would like to be true, into something that we know is true, then we'll be done. So here's the second strategy. Take the whole equality, manipulate it till you get to something which is a truism, something known to be true. Wow. So let's just look at it. So look at this whole equation. What would you want to do to that whole equation to simplify it?
Well, if we can get squares, then we know that we could use our Pythagorean identity.
Mm-hmm. That's true. So one thought might be, I guess you're suggesting like squaring both sides. That would do something. I think that would eventually pan out. You would have to worry when you square both sides of an equation, you might screw up, you might make things that want equal again. So you might screw it up by a plus or minus. So even if you do that and you get down to an equality, you would only know that the original things are either equal or additive opposites. So maybe I'll suggest, like that's something that could work. You would have to think a little bit at the end. But instead, let's look at that original thing. So it's annoying because there's a fraction on both sides. Instead of having a fraction on both sides, what can you do? Yeah, you can cross multiply. You could multiply this over to the other side, the 1 minus sine of alpha to the other side. You could multiply cosine of alpha to the other side. And that resolves equality. You're doing the same thing to both sides. So let's do that. So cross multiplying, I guess we'll get cosine squared of alpha is equal to 1 plus sine alpha, 1 minus sine alpha. Fair enough. Did I cross multiply correctly, or did I screw anything up yet? All right. Well, now there's like an obviously more complicated side, right? There's a side that just physically looks bigger. And it's two things multiplied together. What happens when you FOIL out the right-hand side?
1 minus sine squared alpha.
We've got 1 minus sine squared alpha. So there's cosine squared alpha. And the same thing as 1 minus sine squared alpha. So this is just the distributive law, right? You're distributing multiplication over addition. Maybe it would be. That's the same thing as foiling. Right, FOIL is just that acronym that stands for first, outside, inside, last. But all that is the distributive law that you're using twice, I guess. Okay, cool. So what do you see that looks useful there? And you can ignore the instructions on the left-hand side. What would you want to do to both sides? What would you want to do to that equation to simplify it?
1 minus sine squared theta is cosine squared theta.
Yeah, so maybe instead of saying that, let's say by Pythagorean identity. So we wind up with cosine squared alpha is equal to cosine squared alpha. Is that now a true statement?
Mm-hmm.
Yes. Cosine squared alpha is equal to cosine squared alpha. So this reduces the identity to be proven to a truism, something which is obviously true. So we have proven cosine alpha divided by 1 minus sine alpha equals 1 plus sine alpha over cosine alpha. It's nice to write a concluding sentence, right? We've done something, so we might as well say what it is that we've done. Any questions so far? So at this point, I think what I'll do is, I mean, there are just lots of these left. We won't get through all of them. We have techniques though. So I think, yeah. I'll give you guys a choice. I can talk through another example right now. I can let you guys walk out this one and come up with a proof, and then we'll talk through it together. Which would you guys prefer? How many people would like me to keep on talking? Okay, I'll keep on talking. If you want to collaborate with someone who happens to be next to you instead of walking with me, you can whisper in hushed tones. So let's try to prove that identity. And so maybe I'll say in words one strategy. Is there one side that looks obviously more complicated?
Mm-hmm.
So one thing we could theoretically do is start with that side. And then I guess we could follow an algorithm. We write everything in terms of sine and cosine. Try to simplify, hope that we get down to tangent at the end of the day. Maybe you would believe that some of the intermediate steps would get complicated. Well, shoot, I mean, we've got an idea. Let's chase the idea. So let's start with the more complicated side and simplify it. So let's see. I want to give myself some space to walk it out a different way. So 1 plus tangent psi divided by 1 plus cotangent psi. Let's walk with that. So what would you want to do to that?
Expand it. Meaning that is like 1 plus sine over cosine.
Sure. Tangent is sine over cosine, and cotangent is cosine over sine.
Yep.
We could do that. So that'll give me 1 plus sine psi over cosine psi divided by 1 plus cosine psi over sine psi by rewriting.
A little.
Yes. Yeah, let's
That works.
just turn the brightness down so I think the lamp will light it up enough. By rewriting in terms of sine and cosine. Okay, cool. What next? Yeah.
Then don't you want to put the ones over and have them have the same denominator?
Yeah, let's get some common denominators. So I see 2 fractions added in the numerator. I see 2 fractions added in the denominator. Let's get common denominators for both of them. So I guess that'll give me cosine psi plus sine psi over cosine psi divided by sine psi plus cosine psi divided by sine psi by getting common denominators. And adding fractions. Okay, cool. What else do people, what would you want to do next? Or alternately, was that step, people follow that step? Any questions about what just happened? Yeah.
Yeah, so I guess one question to this, like, couldn't we, I guess, multiply multiply the reciprocal denominator? Is that another way to do that?
Yeah, so.
Or is that what?
So that's only what I'm about to do next, because your fraction in the denominator, so I could multiply by the reciprocal.
Yeah, and then so that's how.
Yeah, that seems like a good next step. Or was there also a question about the preceding step?
I guess I was thinking of multiplying by the reciprocal like a little earlier.
Oh, okay.
That one. That's what I was thinking.
Yeah, so it would be harder to, because this isn't like a single fraction right there yet.
Okay.
So I mean, you could think of it as multiplying by the reciprocal, but it's harder to write down the reciprocal before it's just one fraction. Yeah. That being said, I mean, you could like multiply and divide by, I guess, sine, multiply and divide by sine, and then the denominator would simplify. So you could do stuff like that. There's more than one way to do it, to do this stuff. But yeah, let's instead of dividing by a fraction, I can multiply by the reciprocal. So I see cosine psi plus sine psi divided by cosine psi times the reciprocal of the bottom. Sine psi divided by sine psi plus cosine psi by multiplying by the reciprocal of the denominator. So are there any questions about what just happened? Or does anyone see what they would want to do next? Yeah.
On the bottom of sine side, does that say sine plus the cosine side?
Yeah.
Okay.
Which it better, right? Because that's what I saw in the denominator.
Okay. Just making sure.
Yeah, I guess you have like almost as bad an angle as I do. Yeah.
And then from your page, you just cross multiply it.
Yeah. I wouldn't want to use the word cross multiply, but you're saying like this and this cancel?
Yeah.
Yeah, maybe I just want to say canceling.
Okay.
Equals sine psi divided by cosine psi by by canceling. And what is that?
Tangent.
And maybe I'll do this on like the back page, but I think that I'll delay number 8 for a little bit. So there's one proof. There's more than one way to do this though. Maybe I'll talk through another way which will, so that was all like very algorithmic. You said, okay, I see sines and cosines. Let's rewrite, I see tangents. Let's rewrite all the tangents, all the cotangents, the sines over cosines. And I'll go from there. Maybe I'll suggest this instead. So you'll notice the right-hand side just has a tangent. Can you re-express everything on the left-hand side in terms of tangent? What is cotangent in terms of tangent? Yeah, what's that in terms of tangent? It's like the reciprocal of tangent, right? So I could replace that cotangent with 1 over tangent. Let's try that instead. So here's one proof. Here's another. Right, there's more than one way to come up with a proof for these things. So here's another first step. 1 plus tangent psi divided by 1 plus cotangent psi is equal to 1 plus tangent psi divided by 1 plus 1 over tangent psi, because cotangent psi equals 1 over tangent psi. All right, cool. So do you think, so following almost the exact same algorithm as above, what would you want the next step to be? Yeah.
Denominator one fraction.
Yeah. So in the denominator, I see a 1 plus a fraction. Get a common denominator, add those fractions. Get 1 plus tangent psi divided by, I guess that'll be tangent psi plus 1 all over tangent psi by getting a common denominator and adding fractions. All right, very good. What next? Multiply by the reciprocal of what's on the bottom, so that's the same thing as 1 plus tangent psi times tangent psi divided by tangent psi plus 1. Does something cancel? And so this was by multiplying by the reciprocal. That's the same thing as tangent psi by canceling. Does that reduce the thing that we wanted to reduce to tangent of psi down to tangent of psi? So there's another way. So you'll notice that none of those actually used the comment at the beginning in which I suggest cross-multiplying. So here's yet another approach, which maybe 2 is enough. You could take that whole equation, you could multiply both sides of that equation by 1 plus cotangent of psi. Now you'll see a new equation in which, I guess the right-hand side is complicated looking. The left-hand side is simpler looking, but now you only see multiplication, you don't see division. So that makes it simpler. You could then distribute that out and go from there. So there's yet another way to go there. So infinitely many ways to come up with it. Any questions about stuff so far? Nice. So let's keep on going. So here's one more identity. Let's verify this identity. Sine squared of phi divided by 1 plus cosine of phi is identically equal to 1 minus the cosine of phi. So this time, I think that I do want you guys to do it. Maybe I'll suggest manipulating the whole equation and start by cross-multiplying.
was a 4. This would be 1 times, or 2 times 4, which would be an 8. What's like the justification for that? Just like factoring fractions, or what would
That
you
would be
call
a good
it?
enough thing to call it. Yeah. Somehow you were factoring, or rewriting one thing as 2 things multiplied together. Yeah, that would be it.
Okay. Yeah, that would be another way to do it. Yeah, I think that is much better. And then your question is, distribute this into your top, because it's just sitting there, because we'll have by reciprocal. We're manipulating the signs here, though. Okay, so yeah, you can like. Because yeah, the problem is this is. FOIL here first, to get this, sine squared theta minus sine squared theta cosine theta. And then you factor that together. So I think this needs to be FOIL here, so that you'll have a, I think that might be the issue. Because then the bottom, you notice that Pythagorean identity, you already have the bottom. And then just FOIL the sine squared into your, yeah, yep. I think that's the only thing. Minus cosine theta sine squared theta. Yep. Yep, that's all one big chunk. And then I will factor out on the top, they factor out the sine squared theta. And then the bottom, you know, the sine squared theta. So ultimately, your top and bottom, so you're gonna be like this big one. This can be rewritten, but you're going to factor out sine squared on the top, and then essentially those 2 things will cancel. All your sine squares will go away. So yeah, that's this.
So, in listening, it seems like a lot of people are getting done, and in looking over what people's goals are a little bit, looks like a lot of people are just moving on to the next item on the list. Which I guess is an up and downside to me handing out pre-paired notes. You guys will go at whatever pace you go at. Shall we talk through this one? Cool. So there's multiple different approaches. So the one that winds up being talked through isn't the one that you said. That doesn't mean that you wound up doing was incorrect. Maybe I'll start by doing this. So whenever you see an identity that someone wants you to show is true, the person who's asking you to do that definitely believes that this identity is true. But you should do something to check before you invest too much effort. So here is the plot of those two functions. And let's not try to think about it hard at all. Let's just see what the pictures look like. Do those two things look the same? So I believe that it is, in fact, an identity now. How do you prove this identity? Sure. Let's start by cross multiplying. How many people did that as their first step? Okay, cool. I think we're all. Maybe I can be efficient enough with space. So let's see. By cross multiplying, what do we get? I guess we get sine squared of phi is equal to 1 minus cosine phi times 1 plus cosine of phi. Good. All right. What next?
Foil.
You can FOIL out the right-hand side, I guess. And foiling is a fine thing to say. Maybe I'll even say something more specific to this situation. What we see on the right-hand side is also the difference in squares formula. Saying foiling by the distributive law is also a correct description of that step. But there's maybe something that's a touch more specific. Not that all, just more specific. Okay, cool. What next?
And then we know by the Pythagorean identity that 1 minus cosine squared is equal to sine squared phi.
Yeah. By the Pythagorean identity, we know that 1 minus cosine squared phi is the same thing as sine squared phi. So we get sine squared phi equals sine squared phi. Is that something which is true? Right, it's literally the same thing on the left and right of the equal sign. This is a truism. So sine squared phi divided by 1 plus cosine phi is equal to 1 minus cosine phi is true. Nice. What other approaches do people use? Yeah.
Just a question. So like when we're doing the homework, I guess like how we're doing like by writing out like by the steps for like the sentences, a few of these, is that enough? I guess, like for the amount of detail that you're expecting for us to have on the homework when we prove it.
Yeah. Maybe I'll say that like I'm standing and like hunching over, so my handwriting is really bad. You should try to get your handwriting a little bit better than mine is. And I use a lot of abbreviations. Like you'll notice that I said denominator, but then something like D and O, and then kind of wiggled my pen up and down. Should be a little bit more legible and less abbreviatory than I am. It's hard to write standing hunched over a piece of paper, especially when I can't like go too close to the piece of paper, else I just get a really good view of the back of my head. I guess you find out if I have dandruff. So yeah, this is enough detail that I would want in the homework. I would want maybe. I will suggest that on the homework you do everything twice, because you'll notice that the spacing worked out okay. But now that I know that's the amount of space I need, if I were to go to a clean sheet of paper, I could know in advance how much detail that I need to write and how much space those details will need. So, in fact, the first time that you go through it, you do a rough draft that I'll never see. You don't need to write down all of the descriptions of the steps for your rough draft. Just do something to see if it works out, and then write a clean draft that has all the details. What other approaches do people use? Okay, well, I would say just for the sake of completeness. So maybe I'll say here's another approach. I'll only give the first step. So here's another approach. By Pythagoras, we could get sine squared phi divided by 1 plus cosine phi to be 1 minus cosine squared phi divided by 1 plus cosine phi. So there's another possible first step. From there, I think we could factor the numerator and then see some stuff that cancels. So there's another approach. There's more than one way to prove a thing. So this would be the take the more complicated side and simplify approach. And let's see. With 5 minutes left, I think that the first thing that I want to do is the identity which I skipped. So happily, I've prepared an odd number of pages, which gives me a blank back page. Let's try to complete number 8. Let's verify that tangent of z plus cotangent of z is always the same as secant z cosecant z. How would you guys like to do this?
Simplify the left-hand side.
Simplify the left-hand side. Let's do that. Not the only option, but it's a good option. So let's simplify the left-hand side. So let's see. Tangent z plus cotangent z. What would you like to do to simplify that?
Rewrite in terms of sine and cosine.
Rewrite in terms of sine and cosine. Sine z over cosine z plus cosine z over sine z. By rewriting in terms has an eminent of sine and cosine. Good? What next?
Get a common denominator.
Get a common denominator, and maybe I'll add fractions in that same step. So I guess the common denominator is sine times cosine? Mm-hmm. So I'll get sine squared z plus cosine squared z divided by cosine z sine z by getting a common denominator and adding fractions. Cool. What next?
Sine squared z plus cosine squared z is 1.
The numerator is equal to 1 over cosine z sine z by Pythagoras. All right, what next?
Split the fraction.
Yeah, you can split that fraction. Yeah, no quotes. Right, division behaves well under multiplication, so you can split the fraction up like that. If it were a plus in the bottom, you couldn't. But it isn't. It's times. All right, what next?
Rewrites just secant.
Which finishes. So let's see. There is, I guess, one in the document that I didn't make it to. I saw enough people scribbling that I think a lot of people have completed item 10. How many people did that already? Okay, more than I was expecting. How many people did it by reducing it to item 8? And then saying, well, I know item 8 is true. Yeah, and that's absolutely something you can do on the homework also. If you've proven an identity is true, you can say, well, I've reduced this to a problem blah, 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 which I've already proven is true. Make sure that you really specifically cite what you're doing in that case. Say, well, I know this is true by homework problem blah, blah, blah.
Thursday, you might finish homework on Tuesday.
On Monday, yes.
On Monday.
I'd like to collect next week's homework on Monday, because Wednesday does not exist next week. See, I only remember what the homework's supposed to be once it comes time to grade it. Let's see. This is today, so I want to collect everything assigned last week. Nothing. Okay. 6-1, 6-1, 6-2. Ah, okay.
I just missed you in the very beginning, so I missed you. But yes.
He doesn't come out. Sometimes late. Like yesterday, okay?
Sine squared is 1 minus cosine, and cosine is 1 minus sine, and then you get negative
Who's your boss?
Thanks.
Erica.
Was it what's fair?
Also, there are like 5 Ericas in this class.
He doesn't teach.
That might be an exaggeration, but there are.
Just get paid for making make chemicals.
If you can get it to my office by like the time I leave, that would be cool.
Can I take a picture of this one?
Oh yeah. Yeah.
And then I also have a question on the top one, because I did it differently, because I started doing it before you did it, sorry.
No, yeah. Okay, 8.
But then I got here, and now I don't know what to do.
All right.
Here, sorry.
No, you're good. Let's hit